Right, so this is the gold factor review worksheet. It's not due till next week, and I went through the easy ones already. I'm sorry I forgot to hit record until now. But we're talking about difference of cubes and sum of cubes. Okay? I'm going to do an easy example first, and then we'll come back and talk about the one that's on there. The pattern is simply if you have a u cubed plus a v cubed, you take the cube root of each and you write the factor u plus v. Now watch my little arrows closely here, okay? Then you square this one and you square this one and put it at the back. And then in the middle you do this times this, which is a uv. And if this was a plus, this stays a plus, and this one goes minus plus. Okay? I don't know if you remember this pattern from last year. Let's make up an easy one. M cubed plus 8. Does everyone understand that 8 is a perfect cube? You would have recognized that one. 2 times 2 times 2. Okay. What is the cube root of each of those? Okay, so we have an m plus 2. Then the second parenthesis, we square that one, so we write m squared. And we square this one and put it at the back, which is a 4. And it's always a positive at the back. In the middle, you multiply these together, but you change the sign. So this becomes a 2m, and if this one was plus, this one is minus. Now, some of you are going to look at this second parenthesis back here and think this should factor further. Okay? Does it factor m minus 2, m minus 2? That would give us an m squared and a plus 4, but in the middle we wouldn't get a minus 2m, right? As long as this was simply the difference of two cubes with no common factor, it won't ever factor any further than this pattern. All right, can somebody find one that seems pretty easy that's perfect cubes? You know what? Before we do that, can you write these down the corner of your paper? What's 1 times 1 times 1? 2 times 2 times 2? 3 times 3 times 3? 4 times 4 times 4? 5 times 5 times 5? Anybody know 6 times 6 times 6? 7 times 7 times 7? What are we on? 8 times 8 times 8? 9 times 9 times 9? And 1,000. So there's the first 10 perfect cubes. So look for those numbers when you see the other part of the problem is a cubic. Can you find one for me?
4.
Number 4? Okay. Number 4. So how's number 4 going to go? A plus 3 in the first. Good job. We square that one. Nope. Once you've cubed it, kind of ignore this one, okay? The back is going to go, the 3 squared is 9. And the middle is, yep, minus 3a. Good job. All right, the same is true for a minus in the middle. It just switches signs. So the difference of perfect cubes is the same. Let's do number 7. That looks just evil, doesn't it? These are all perfect cubes. What would be the cubed root of c to the 6th? Do you guys remember this? That cubed root means to the 1/3 power. So it is going to be c squared. It should make sense that c squared times c squared times c squared, which is c squared cubed, gets you back to c to the 6th. Yes, all that's tying together in your little brain. All right. So what's the cubed root of 125 c to the 6th? Okay. And the cubed root of 8 is 2, so we have a minus 2, and the cubed root of m to the 6th is, okay, now, gets a little messy. We have to square this. 5c squared times 5c squared would be, good job, Besma says 25c to the fourth. Everybody okay? The one at the back is squaring this guy. 2m squared times 2m squared would be 4m to the fourth. The sign changes, yep, so it's going to be plus, and it's one of these times one of these, which is, yeah, c squared m squared, and I can't really squeeze that in there. Let me rewrite that much nicer. 5c squared minus 2m squared times 25c to the fourth plus 10c squared m squared plus 4m to the fourth. Now, again, some of you are going to look and that should factor, that should factor. But if you try to factor it as 5c squared plus 2m squared, when you do the middle terms, you'll get 20 c squared m squared instead of 10. It doesn't factor any further. All right, do you kind of remember difference in sum of cubes now? All right, I got 5 minutes left. I want to talk about when you have 4 terms, do you remember factor by grouping? Okay, so on the first 2 terms, they took out 2a squared. Now, on the back, they could have taken out 5 or a negative 5. Why did they choose a negative 5? The parentheses have to be the same, okay, guys? You can't do any grouping if you can't pull that same parenthesis out of both. So then I take out the a minus 2 from both, and the leftovers go in another parenthesis. Can anybody find one of these for me on the worksheet? 22, somebody said? 22. Actually, 22 doesn't work. Do you see the little stars? I'm going to talk about the little stars in a minute. But it does have 4 terms. 18? Okay, what can I take out on 18? The first 2 terms I can take out. X squared will be left in x plus 2. Then on the second set of 2, I can take out a plus 3, and left will be x plus 2. Then I can take out an x plus 2 out of both, and the leftovers will be an x squared plus 3. And that doesn't go any further, right? Okay. All right. I have 3 minutes left to talk about this really weird, crazy business with the star. This pattern with the star, we'll see if anybody remembers doing this last year.
I do remember.
All right, let me go. I may take 5 minutes, okay? But let me talk about this. I love this because it's just a math pattern. Does this look familiar to everybody? It's called Pascal's triangle. Okay. What this? Yeah, it's okay. And we're going to learn this in depth next semester when we do some combination problems and stuff. But today, guys, what we're using this for is that a plus b to the 1, the coefficients would just be 1a plus 1b. Everybody good? If I had a plus b squared, this row tells me that the coefficients would be 1a squared plus 2ab plus 1b squared. If I had a plus b to the third, it would be 1, 3, 3, 1 are going to be the coefficients. The a is 3 times. Then there's 2 a's. Then there's 1a, and at the back there's no a's. So see how the a goes a3, a2, a1, no a's. The b is doing the opposite thing. So there's no b's, 1b, 2 b's, and 3 b's. So if you memorized parts of Pascal's triangle, you could say that a plus b to the fourth, okay, help me out here, guys. What are the coefficients going to be? 1, 4, 6, 4, 1, and I'm going to run out of room, so I'm going to do it that way. Okay, then it starts out a to the fourth and no b's. This one gets an a to the third and 1b. This one gets an a squared, b squared. Do you notice what the sum of the coefficients always is? The exponents, I mean. They always add up to 4. Okay? So this one gets 1a and 3 b's, and this one gets a b to the fourth. Okay. Now, how do you know these numbers? Well, look at the patterns here. This one goes 1, 1, 1, 1. This one goes 1, 2, 3, 4. Or you add these together. You add a new 1, and then you add these 2 together. You see what I'm doing? Okay. They are also combinations later. Okay. Crazy business. So this concept is if you recognize a 1, 3, 3, 1, it may be a quantity cubed. Okay? If you recognize a 1, 3, 3, 1, it may be a quantity cubed. That being said, I am not going to ask you to do this on a test or quiz. Therefore, I give you a very, very subtle hint which ones might use that pattern. Anybody have a suggestion? Okay, so pick one for me.
23.
24? Doesn't matter. Let's do 24 because I have room down here. This is 1, 3, 3, 1 in a different way. What is the cube root of this one? Y. What is the cube root of this one? Okay. This is really all you have to do and you're done. Okay? Now, let me prove to you that it works though, okay? If we wrote out 1, 3, 3, 1, you would take this one and cube it, so you'd get a y cubed. This one would have a y squared, this one would have a y, this would have no y, right? But the 10, this one would have a 10 cubed, a 10 squared, a 10, and no 10s. Is that equivalent? 10 times 3 is 30y squared, yes? 3 times 10 squared is 300y. Okay? Otherwise, we could play fun with foiling for a while and do this. Okay? All right. I'm done. I'm not going to talk about any more about this today. It is due next week. You can ask questions on it next Monday and Tuesday. The reason I'm giving you today, because the rest of the hour today is about answering questions on 9, 10, 11, 12, and 13. It's time to work on 9, 10, 11, 12, and 13. Okay? But since I had nothing else new, I taught you a little, reminded you a little bit about this so that this weekend you can get started on this. All right. Can I help somebody with 9, 10, 11, 12, or 13? Okay. Oh, Claire, then you can have the copy I printed. But yes, absolutely. Guys, let's look at 9B. 12 you want to do?
Yeah.
Okay. There is one question like this on the test.
Oh my gosh.
What? 9B is on the homework, yes. The homework check is listed up here. In the middle of the board, it says homework check 5 in red box up here. It says 9 A and B, 10 A and B, 11 A and B. 12, you only have to do B 1 through 5. And 13 A, you only have to do 1 through 6, and B 1 through 8. And I will tell you 11, 12, and 13 are all multiple choice questions. Almost all, anyway. Yeah. Except I told you to add back in 9B and 10, yes. All right, guys, this is worksheet 9B. It says a ballpark concessions manager finds that each vendor sells an average of 40 boxes of popcorn when 20 vendors are working. So if, okay, let me write vendors. Pretend that says vendors, okay? There's 20 vendors working. This is the number of boxes per vendor. They sell 40 boxes per vendor for total sales of 800 boxes. Are we good so far? For each additional vendor, they will each average one fewer box. So if he hires 21 vendors, then only 39 boxes will be sold. If he hires 22, then only 38 will be sold, and so on. Okay? Yes, the numbers are the same as one of the questions on the other. This is going down up by ones, yes, starting at 20, and this is going down by ones. And we're trying to find the maximum of that. So you can literally graph that parabola and find the maximum. Claire, if you wanted to do it algebraically, you could FOIL it together. And then use negative b over 2a. Negative 20 over 2a would be negative 1 times 2, right? So you would get 10. So the maximum occurs, is that right, guys? Did I do something wrong? Did anybody, what is the answer from yesterday? It was 10, okay. The max is at 10, and X was the number of additional vendors. I should have written that down right away. So if we add 10 vendors, we'll be up to how many? You got to plug it back in over here. So we'll have 30 vendors. And if we put it in here, 40 minus 10, we would each sell 30 boxes each. So that would be a maximum of 900 sold. Does that help, Claire?
Yeah.
Now, the one above it is similar. Just be careful because, like, it starts with $4 per ticket, but it says each 20-cent increase. So this is going to be 4 minus point decrease. Yeah, thanks. So X is the number of decreases. And this started with 400. And every time they knock it down, 40 more people will come. So this is going to be 400 plus 40 per decrease. Do you understand where those numbers are coming from? Because it's not just going down $1. They're putting it down by 20 cents. That's where the 0.20x. And increasing by 40 people. So 400 plus 40x. And then you multiply those together and find the maximum. Oh, good job. Absolutely.